I'm gonna steal the screen share back.
And so up next, we have Sarah Blunt from Caltech, who is going to be telling us something we all need to know, which is how to be better coders.
Thanks, Paul. Hi everyone. I'm Sarah Blunt. I'm a graduate student at Caltech. I'm excited to talk to you a little bit today about Code Astro, which is a week-long workshop that I and my co-instructors, Jason Wong and BJ Folted, and my teaching assistants listed on the screen, ran back in, actually, I don't remember. I think it was June or July. Time has no meaning anymore. Oh well, it was either June or July. So why did we decide to make this workshop? Explained by a couple of memes. And also, so most astronomers have no formal education in programming. A couple of us have like taken a computer science class or two in undergrad. Many of us haven't. There's no real process for astronomers to practice and learn good coding habits. And as we all know, this causes things like bugs in our code, poorly documented or hard to read code, code that isn't reproducible, or code that's really inefficient. And also, not for nothing, it makes us feel really bad. So we had applications for this workshop, and we asked people, why do you want to participate in this workshop? And one of the most common answers was like, I don't feel like I'm good enough at coding to do my research, or like I feel like my coding ability hinders my research ability. So increasing people's confidence in coding was also a big goal of this workshop. So we spent 5 days, I guess it was June, that's good to know. We spent 5 days covering practical topics. So on Monday, we started from the very beginning, talking about different programming paradigms, functional versus object-oriented, etc. programming. We also talked about the philosophies of different Python packages. So like how to best use NumPy, for example, how to best use pandas and matplotlib. We also discussed different development environments. So when you should use Jupyter notebooks versus when you could use IDEs. We also, throughout the workshop, encouraged people to use VS Code and demo different features of this environment. On the second day, we talked about Git and GitHub. We talked about how Git and GitHub work under the hood, and also gave practical instructions about how to use them. We did a debugging tutorial. And then as the week went on, we talked about releasing code, documenting code, profiling code, testing code. We did a brief lesson about parallel programming. We talked about discrimination in coding and how to enforce anti-discriminatory practices in your coding and collaborations. And on Friday, the last day, we did a panel discussion with people who had industry experience and talking about the differences between developing software in industry and academia. And then we also gave people time to present their projects, which I'll talk about a little bit. We set very specific project goals for participants. So we showed this slide at the beginning of every single day of the workshop. The three main goals were, by the end of the workshop, for participants to be able to use the language of software development. So we were very intentional in like using and building up participants' vocabulary. Developing and releasing an open source astronomy package from start to finish. So we wanted people to be able to code up something, test it, document it, and release it to the community by the end of the week. And also write code that follows best practices of software development. Participants also worked on a final project throughout the week. So I alluded to this a little bit earlier. The final project, as I have sort of said before, was required to be fully documented, well-tested, open source and hosted on GitHub, and also collaborative. So you were required to work in groups of 2 to 4. So several people had to be able to make Git commits to the same project. And yeah, so the projects that were presented by the end of the week completely blew us away. So I've listed some examples here, but there were many practical examples that of projects that people used for their research or just for fun. And the amount of stuff that people were able to put together in a week was amazing. We had over 50 participants from around the world. This was a really unexpected, nice consequence of COVID, was that we had originally planned for this workshop to be in person, and so we thought that it would be limited to people at Caltech. But because of the shutdown, we opened it up to people around the world. So here's our equivalent of a workshop photo at the end of the workshop. So I wanted to briefly talk about things that I thought worked, especially since we've been discussing during this meeting a lot of like how to do a good workshop on Zoom. So some things that worked for us were first keeping lectures to less than 20 minutes. I think Jason was the one who said that this is the longest YouTube video you could be expected to watch. So we made sure that we kept lectures pretty short. We had multiple instructors teaching each day. We also did a full content review with the TAs ahead of time. So there was very little material that was being presented to students for the first time. The TAs had also been taught the material. We also tried to keep the lessons as interactive as possible. We had lots of demos, and we also broke people up into small groups for activities. We also wrote up a code of conduct ahead of time and discussed it extensively and shared it with participants, and I thought that was a useful thing to have. We also set multiple ways to participate in the workshop. So participants could either be there in real time and like log on at 9 a.m. Pacific time and stay throughout the day. We also recorded the workshop, so if people weren't able to participate in real time, they could participate asynchronously. And we also had an option for people to not do the final project at all and to just watch the lectures. Also, advertising worked a little too well. We actually were worried about having too many people sign up and not being able to handle the number of people that signed up. So we tried to limit the advertising that we did as much as possible. And we still got too many people. So things that we need to work on for next time, this is based on feedback that we got from participants. First was we didn't leave enough time for group work activities. And one of the most common complaints was that people weren't able to finish the activities in the time that they were given. And another thing that we've talked extensively about is installation woes. Another sort of side goal that we had for this workshop was for people to be able to manage their own environments on their computer. We wanted people to be able to, install Python in the way that they want and manage their own Python and Conda environments. And that was a noble goal, but it led to a lot of difficulties. So in the future, we could potentially have a virtual environment available as a backup for people to use if they don't get the installation worked out in time, or also just spend more time and have more help available for installation. So just wanted to include a slide bragging about the fact that participants enjoyed themselves. These are some quotes from the feedback forms that we received. So I'll just highlight one or two of them. So one person said, "I like the structure, the combination of theory and practice, the dynamics of the breakout rooms, and especially the kindness of the instructors." Another person said they loved the pace of it. The short but thorough lectures and exercises were a great approach. And yeah, I won't read the other two. People liked it. So I wanted to wrap up, but before I do so, I wanted to advertise my 3 amazing students who are all presenting posters at this conference, Rodrigo, Sophia, and Vignesh. So make sure you check out their posters. They're talking about really exciting direct imaging and radial velocity science. So I will leave you with a link to our completely open source curriculum and materials and a meme. Thanks.
Okay, thanks so much, Sarah. Looking for questions. First question, and maybe this URL in your last slide answers it. Are the recordings and slides still available online so that we can all benefit from those?
The recordings are not available, but the slides and materials are all available here. Yeah, I don't think we're planning to make the recordings public, but we're
Okay.
also going to host this again next year. So if you'd like to participate in the future, you can.
Okay, so you have preempted the next question, which is, will this be held again in the future? Who is eligible to apply and attend?
Yeah, we're still figuring out the logistics of what it's going to look like next year. So I don't want to say anything and be wrong. But we would like to make it open to people of all career levels. And this workshop is open to people of all career levels at any institution. So we'd like to keep it that way, but pending funding and all that sort of stuff.
Okay. And one last question that I had, you had this really nice recap of what went well and what didn't. If somebody wanted to take this model and use it in a classroom, sort of as a section on a, physical sciences data analysis course, are there any sort of changes or modifications that you would recommend for that?
Yeah, I think the main modification that you'd have to make is trimming down material. So this was designed to be 40 hours of material, which might be too much for like one module of a class. So I think we've done a reasonably good job of like ramping up the relevance and also difficulty of topics. So the topics at the beginning of the week should be more general and foundational. So I would encourage people to look at those first, and then have maybe some of the activities and materials towards the end of the week as like additional optional activities for people who wanted to learn more.
Okay. Well, thanks again, Sarah. This is really exciting stuff. And we are rounding